Hello, this is Brenda Wingard-Haynes, and this is Chem 207, or maybe Chem 209, and this is Unit 6, Redox, Introduction to Nuclear Chemistry and Introduction to Organic Chemistry. Redox is completely new for people who've taken 110. 110 does not cover redox, which involves transfer of electrons. This means that something has to gain electrons and something else has to lose them. So there's a good mnemonic here that you may have heard before. Leo the lion goes grr. Loss of electron is oxidation. Gain of electron is reduction. You may have also heard of the acronym oil rig. Oxidation is loss, reduction is gain. In its simplest terms, we can identify a redox reaction from half reactions that have the spectators canceled out. If we go from copper, which is a solid, to copper 2, which would infer that it has to be aqueous, in order to go from neutral to +2, we have to lose 2 electrons. 2 positives plus 2 negatives equals 0. Therefore, the copper that we've started with is oxidized, and this is the oxidation half reaction. Now, if we're going to lose these 2 electrons, they have to be gained somewhere else. So, for example, if we go from tin 4 to tin 2, those 2 electrons have to be gained. 4 pluses and 2 minuses equals +2, and therefore tin 4 has gained these 2 electrons, and therefore it is reduced. Or we could say this is the reduction half reaction. Where do the electrons go? They are transferred. Which is the oxidation half reaction? Copper to copper 2. Which is the reduction half reaction? Tin 4 to tin 2. How many electrons are involved in the transfer? 2, not 4. These 2 electrons that are lost are the same 2 electrons that are gained. What happened to the anions? They're spectators. And if we have these 2 half reactions, we're going to add them together. The electrons will cancel. 2 halves make a whole. And we end up going from copper solid plus tin 4 will yield copper 2 plus tin 2. And this is our skeletal balanced reactions. And the sum of the stoichiometric coefficients is 1 plus 1 plus 1 plus 1. Now remember, if you've been in my classes before, that you know that the sum of the stoichiometric coefficients is just a way to make something like this something that you can put on a multiple choice test. Okay? Now if we go from gold to gold 1, we have to lose 1 electron, so the gold is oxidized. Tin 4 to tin 2 has to gain 2 electrons. If gold only gives off 1 and tin needs 2, how is tin going to get 2 electrons? Well, it will achieve it if it can recruit 2 golds. Where do the electrons go? They are transferred. Which is the oxidation half reaction? 2 golds yields 2 gold ions plus 2 electrons. This whole reaction multiplied by 2. Which is the reduction half reaction? This one, because these are gained. 2 electrons plus tin 4 yields tin 2. How many electrons are involved in the transfer? It has to be 2. What happened to the anions? They are spectators. What is the sum of the stoichiometric coefficients in the balanced equation? When we distribute the 2 electrons will cancel. So remember, we'll end up with a 2 here, a 2 here, and a 2 there. So we get 2 gold plus tin 4 yields 2 gold ion plus tin 2. By the way, we're ignoring the activity series just in case anybody's paying attention. But nonetheless, we're going to assume this goes forward for the sake of practice. So our sum is 2 plus 1 plus 2 plus 1. 2 plus 1 plus 2 plus 1 equals 6. Okay? Page 2. Let's try again. Positive 2 to positive 4 means we have to lose 2 electrons. Positive 4 plus negative 2 equals plus 2. Chromium 6 to chromium 3 means we have to gain 3. You cannot lose 2 and gain 3. So whenever you see 2 and a 3, that tells you you're going to make 6. So we're going to multiply by 3. We're going to multiply by 2. What is oxidized? Lead 2. What is reduced? Chromium 6. That's the same as saying the half reaction, except instead of writing the whole reaction, we're just taking what is actually oxidized and what's being reduced. How many electrons involved in the transfer? 6. What happened to the anions? They are spectators. What is the sum of the stoichiometric coefficients in the balanced equation? When we distribute the 3, we're going to end up with 3 lead 2s, 3 lead 4s, 6 electrons. When we distribute the 2, we're going to have 6 electrons, 2 chromium 6, 2 chromium 3s. We add those together, the 6 electrons transfer. We end up with 3 lead 2 plus 2 chromium 6 yields 3 lead 4 plus 2 chromium 3. So the sum is 3 plus 2 plus 3 plus 2 equals 10. Okay? Now what if we go the other direction and instead of having the 2 half reactions, we start with something like this? Well, we can pull out the half reactions and assign electrons. Iron to iron 2, iron 3 to iron 2, means we have to gain 1 electron. Positive 3 plus negative 1 equals positive 2. Copper to copper 2, that's the other half reaction, means that we have to lose 2 electrons in order for our 0 to equal 0 on both sides. Notice we have 1 electron gained, 2 electrons lost, so this entire half reaction has to be multiplied by 2. 2, 2, 2. Cancel out our electrons, and then we can add the 2 half reactions and get our stoichiometric coefficients over here. What has been oxidized? Copper. Copper loses these electrons. Which is reduced? Iron 3. How many electrons involved in the transfer? 2. What happened to the anions? They're spectators. What is the sum of the stoichiometric coefficients in the balanced equation? 2 iron 3 plus copper yields 2 iron 2 plus copper 2. Notice that if you just look over here, you might say 1 iron, 1 copper, and you would think that equals 4. But you have to balance your electrons first, and you end up with this. So our sum is going to be 2 plus 1 plus 2 plus 1 equals 6. Okay? And then last in this segment is going to be the familiar single displacement, ZnCl2 plus H2. Will this reaction go forward? Yes. Z is higher than hydrogen on the activity series. We recognize this as single replacement. Write a net ionic equation. This is why we've spent so much time on net ionic equations. Zinc plus H plus, if this is total molecular, our total ionic equation, Cl minus, Zn plus 2, because remember this is going to be aqueous, plus 2 chlorides, plus H2, which is a gas. Chlorides will cancel. Zinc plus 2H plus yields zinc plus 2 plus H2. Oh, here comes my kitty. Okay, so zinc to zinc plus 2 is showing oxidation. H plus to hydrogen gas is showing reduction. Okay? So Zn plus 2H plus Zn plus 2 plus H2. Okay, so let me make this obvious. Zinc to zinc plus 2 has to lose 2 electrons. That's the only way that our charges can balance on both sides. So the zinc is oxidized. 2H plus 2 electrons yields hydrogen gas. Again, 2 pluses, 2 minuses, we end up with something that has 0 charge. How many electrons involved in the transfer? 2. What happened to the anions? They are spectators. And what is the sum of the stoichiometric coefficients in the balanced equation? Well, this is going to give us the same numbers as what we have over here. 1 plus 2 plus 1 plus 1, which is 5. 1 plus 2 plus 1 plus 1, which is 5. And we were able to balance this because we had these spectators which weren't canceled out. Other times we end up with our skeletal equations like what you see up here, and we have to put our electrons in. In the next segment, we are going to continue working on redox, and we're going to see that as we move forward, redox will not be quite as obvious as what I'm showing you.